Okay, hello everyone, good morning, nice to meet you all. Thank you for watching my video. I am Nuramanah from University of Indonesia. I will present about my research. The title is In Vitro Formation of Adduct 8-Hydroxy-2 Deoxyguanosine DNA against deoxyguanosine with the influence of nickel 2, copper 1, and copper 2 metals. Okay, next, the content in our video. In my video, there are abstract, introduction, experiments and method, result and discussion, and then conclusion. Okay, for abstract, determination of 8-hydroxy-2 deoxyguanosine in this research is form of biomarker that can be used as an early detection of DNA defects due to long-term xenobiotic exposure can trigger cancer. In vitro studies in this research, directing one of the best DNA is 2-deoxyguanosine, which is presented with the metals nickel, copper 1, and copper 2 as xenobiotic compounds assisted by hydroxy peroxide. The reaction is carried out in a temperature of 37 degrees Celsius for 24 hours in an incubator shaker. Variations in this study were at pH 7.4 and 8.4. The product of the reaction were analyzed using reverse phase HPLC instrument using phosphate buffer and methanol osmosis phase with a ratio of 85 and 15. The formation of XOSDG from the interaction of 2-deoxyguanosine with the 3 metals and the addition of hydrogen peroxide at pH 8.4, temperature 37 degrees Celsius for 24 hours is higher than the interaction at pH 7.4. In more alkaline pH, causes hydrogen peroxide to decompose more, thus increasing the formation of free radicals as the cause of the formation of HOSDG. Okay, for introduction. Okay, next introduction. So, HOSDG or 8-hydroxy-2 deoxyguanosine as a biomarker, and we can find this product in urine, blood, and tissue. And HOSDG is a product of oxidative DNA damage caused by attack by reactive species, oxygen species, or we can call ROS. So ROS are generated during normal cellular metabolic processes and also after exposure to harmful environmental factors such as ionization, radiation, and carcinogenic chemicals. And ROS is a collective term that includes oxygen radicals such as hydroxyl, peroxyl, superoxide, and hydroperoxyl radical. Some non-radical oxidant agents such as hydrogen peroxide, acid hypochlorite, and ozone. And copper and nickel metal, they are widely distributed in nature and include important elements. And copper and nickel act as catalysis in the formation of phantom. Copper and nickel act as catalysts in the formation of reactive oxygen species through the Fenton and Haber-West chemical reaction and catalyst lipid peroxidation of membranes. So the purpose of this study is to see the formation of HOSDG, which is one of the oxidative DNA from the DNA-based guanosine with the influence of nickel, copper 1 and copper 2, and hydrogen peroxide as a radical source by adhering to principle of the Fenton and Haber-West reaction at 37 degrees Celsius and pH variation for 24 hours incubation. Okay, for the next is experiment and method. So in the experiment and the method, I use SPLC instrument. The kind is Thermoscientific Ultimate 3000 instrument with a UV phase detector at wavelength of 254 nanometer. The mobile phase used was sodium hydrogen phosphate buffer 10 millimolar and methanol with the ratio of 85 and 15. Flow rate of 1.2 milli per minute, and the type of column used was C18. Okay. In this study, there was 3 ways to see the formation of HOSDG. For the first, without hydrogen peroxide, with hydrogen, and second with hydrogen peroxide, and the last is mixed two type of metal and hydrogen peroxide. For the without hydrogen peroxide, 100 microliter 2-deoxyguanosine concentration 10 ppm in 0.1 molar potassium phosphate buffer pH 7.4 and 8.4 reacted with 100 microliter nickel metal 2 concentration 100 ppm or 100 microliter copper 1 concentration 100 ppm and 100 microliter copper 2 concentration 100 ppm, then incubate at 37 degrees Celsius for 24 hours. And then with hydrogen peroxide, 100 microliter 2-deoxyguanosine concentration 10 ppm in 0.1 molar potassium phosphate buffer pH 7.4 and 8.4 reacted with 100 microliter nickel metal 2 concentration 100 ppm or 100 microliter copper 1 concentration 100 ppm or 100 microliter copper 2 concentration 100 ppm and add 100 microliter hydrogen peroxide concentration 100 ppm, then incubate at 37 degrees Celsius for 24 hours. And then the last mix with the same concentration ratio, but only 2 types of metal are added to each reaction. Okay. Sorry. Maybe this is a little picture related to the procedure that has been done. So in the glass reaction, 2-deoxyguanosine with the metal and hydrogen peroxide, and we have to shake for homogen, and then have to incubation on 37 degrees Celsius for 24 hours in incubation shaker. And after this, we have to analyze it with HPLC, and then this is chromatogram that will appear on the HPLC instrument computer screen. Okay, and then the result and discussion. Okay, for result and discussion, previous research has shown that metals such as nickel and copper contribute to the formation of free radicals using the phantom-like chemical reaction principle. The free radicals that are formed can attack DNA base, one of which is easily attacked by free radicals is guanosine 2 from DNA adduct of HOSDG due to the addition of hydroxyl group at C8 guanine base. So in the figure 1, to explain about structure of modified deoxyguanosine, DNA guanosine have to attack the free radical to be oxidative straight DNA, and then forming DNA adduct HOSDG because addition of hydroxyl group in CS and then to be HOSDG. Sorry. For the figure 2, the showing about chromatogram standard HOSDG 1 ppm in HPLC. So in the standard have a retention time 5.413 minutes. And then for the figure 3, to showing about calibration group standard HOSDG for analysis in standard 1 ppm until 5 ppm. So value of regression in 0.9985. Okay, the effect of hydrogen peroxide on the formation of DNA adduct HOSDG. In addition of hydrogen peroxide, the adduct of HOSDG is formed if compared to not adding hydrogen peroxide. This can be seen in figure 4, 5, and 6 next. Without the addition of hydrogen peroxide, the reaction for the formation of hydrogen peroxide is difficult to form. That because hydrogen peroxide is strong oxidizing agent, without the presence of hydrogen peroxide in the reaction of metal cannot be oxidized, and the formation of free radical result in the formation of HOSDG reaction that do not occur. This is an accordance with the principle of the phantom reaction with the organic compounds are oxidized with iron, such as the following equation like this. Okay. Okay, we can see difference of this chromatogram with the addition of hydrogen peroxide and without hydrogen peroxide. In the figure 4, to showing chromatogram for after reaction of 2-deoxyguanosine with nickel 2 and hydrogen peroxide. So we can see in the retention time 5.352 as HOSDG. Why? We have to compare with the previous standard HOSDG like this. And then the figure 5, chromatogram reaction to deoxyguanosine with nickel 2 without hydrogen peroxide. In the retention time, 5 minutes, didn't have a peak. So without hydrogen peroxide cannot form it HOSDG. Okay, sorry. In the figure 6, to showing the addition of hydrogen peroxide in the formation of HOSDG for 24 hours at 37 degrees Celsius and pH 7.4 and 8.4. And then in this graphic, without hydrogen peroxide cannot form it about HOSDG like this. Okay. The effect of addition of two metals on formation of HOSDG. Okay. DNA adduct in the reaction by adding symbiotic compounds in the form of two types of metal in one reaction. It gives us a synergistic effect with the formation of more HOSDG DNA adduct than only one metal. The addition of metal greatly affects the formation of free radicals. The presence of peroxides will oxidize metal so that free radicals are formed. In the previous in vitro studies using salmon sperm DNA, which was incubated together with hydrogen peroxide and mixture of metal forming HOSDG gave a synergistic effect. The metal mixture reacted with DNA produced more HOSDG. And then the figure 7 showing about effect of the addition of two metal in one reaction on the formation of HOSDG at 37 degrees Celsius and 24 hours of incubation. So have two metal concentration formation of more HOSDG DNA than single metal like this. Okay, the figure 8 showing about chromatogram 2-deoxyguanosine with copper 1 and copper 2 and hydrogen peroxide, and have retention time in 5.873 as HOSDG. Okay, the effect of pH on the formation of DNA adduct HOSDG. Increases level of HOSDG occur at pH 8.4 compared to pH 7.4. This is because hydrogen peroxide is a weak acid which will be more stable in acidic pH. So that in alkaline atmosphere, it increases the occurrence of decomposition, which will occur significantly and perfectly at pH 5 until 11. Decomposition causes the formation of hydroxyl radicals. The more hydroxyl radicals produced, the more HOSDG formed. So the figure 10 to showing effect of pH on the formation of HOSDG. In the graphic, pH 8.4 more than high for forming HOSDG than pH 7.4. Okay, next is conclusion. For conclusion about my research are the reaction between 2 deoxyguanosine added nickel, copper 1 and copper 2, and hydrogen peroxide to form HOSDG as DNA oxidative stress. The concentration of HOSDG increased with the addition of metal, which give a synergistic effect. At pH 8.4, the concentration of HOSDG produced was higher than at pH 7.4. As treatment at 37 degrees Celsius and for 24 hours incubation. Okay, there are a list of reference that I use. Okay, so thank you so much for watching my video, and if you have to know about detail my my research, you can write in comment column. So thank you so much, and I think enough. So see you, and wassalamualaikum warahmatullahi wabarakatuh.